Our next presentation today will be given by Dr. Christian Schubert. Dr. Schubert is system expert of automation at Infineon, right here in Dresden. His topic is Base Sorter 300, how to run experiments in a highly automated fab. So with that, Dr. Schubert.
Yeah, thank you very much. As a part of an internal training program at Infineon, there is 10 colleagues, and including myself, were given a very interesting automation challenge. And this challenge was about to integrate sorters into our experiment management system. And during the course of the project, we gained some very interesting insights, which I want to share with you today. When I started at Infineon 1.5 years ago, I was really amazed how far we've got with automation. You can see the picture here. It's taken from our 200mm fab, just right over there, really. And so the automation is really almost complete. So we automated processing of the equipment. We automated transport to the system, to the equipment, and the scheduling of the lots is also done online and optimized. And this is the key factor why Infineon can afford to have a volume production of microchips here in Germany, which is a high-cost country. And something special about the fab is that we have a high mix in Dresden. This means we have several hundred different products, ranging from simple MOSFETs to more complicated MEMS and integrated IGBTs. And due to the large number of products and their life cycle, there's always some products which gets introduced into our fab and which is being ramped up, ramped down. And this means we are always doing development work and to bring these new products into production. And this development work could entail qualifying new processes, integrating new tools, or even integrating new logistics if you have different substrate types, for example. So really, development is one of our daily businesses. And now, here at Infineon, we do development right next to production. So we use the same tools for production as for development. So we don't have dedicated tools for it. And this is really interesting because having an automated production is one thing, but having an automatized development is a completely another topic. So how could it have looked if you don't automate your development? Well, I will try to illustrate this for you. This is Bob. Bob wants to run an experiment because his boss told him to get his process qualified very soon. So he put a lot on hold, which he wants to use for his experiment, and then sends an email to his operator friend called Richard. And in his email he writes, "Hey Richard, please, could you rerun the last experiment with my lot and increase the temperature by 10 degrees? Now, there's a problem because Richard has got a new girlfriend. And so he went on holiday with his new girlfriend, and so he has taken the time off. Now, Bob has found another operator, which is called James. However, James is new to Infineon, so he doesn't know the tools, and he doesn't know what Bob meant in his email. So he went back to Bob and asked him, what should we do exactly? Together, they worked out what Richard has done on the equipment and finalized the specifications. So James could go off to the tool and run his experiment. Unfortunately, after he's done his experiment, he's forgotten to turn the tool back into automatic mode. So it was actually idling for 2 hours, and it took a while, and some moves were lost. And then when the results got back, Bob noticed that James did the experiment on the wrong equipment. Richard would have known, but James didn't. So the boss of Bob wasn't happy at all. And this is really the problem if you don't automate your development. Your definition is a free text, you do manual execution, and you have many lot holes. And development often adds to time to market. So back, I think, in 2010, Infineon and SYSTEMA started together a project which is called the Experiment Management System. And the aim of the project was that we automate our development. So this project has long been finished, and it has been introduced into our fab. And now such an experiment would look like this. Again, Bob wants to run an experiment. He's now got a software where he can enter the experiment and describing in a formal way what the experiment should look like, which lots it should be acted on. And this, by the click of a button, is sent to our MES system, which knows how to run experiments and can execute this experiment within our automated production using the same methods and systems that are there for doing the automated production. And this means we have no lot holes, no interrupts. We gain traceability, we gain quality because operators don't handle it manually anymore. So this experiment management system is most commonly used for, or I would like to give you an example of what it's commonly used. Normally, you have a lot which travels through a process, and this process consists of process steps. And at each process step, a recipe is run. So, say for example, this is our recipe. Now, if we want to do an experiment, we define an experiment, and we take the same route and simply replace the recipe and maybe dedicate it to an equipment. This is what our experiment management system is mostly used for. Another most important type of experiment is this. You take a lot here, and a lot typically consists of 25 wafers, and then you send 13 wafers along the normal route, and 12 wafers you take and run the experiment on them, and then combine them back together. And because this is better for statistics, because the variation here is very low, and so the results are better to compare. But in order to do this, you need to split and merge the lot. Splitting means you take the lot, drive it to a sorter, and then the sorter takes out 12 wafers, put it in a new cassette, and so you have 2 lots. And afterwards, you merge them back together, so 2 lots get on the sorter, and they are merged back into one. However, this didn't work a year ago, because our sorters haven't been integrated into experiment management system. And this is the task we were set to do. So why is that? Why hasn't it been done yet? Well, to put it short, we had different things to do. But also, sorters are, well, like an illegitimate child, really. This is what a sorter looks like. Very clean, simple, and, well, people don't really like sorters. We see it. When you ask process engineers, especially from lithography, who have very expensive and fancy tools, they will tell you something like this. Well, they don't add any value. And if you ask others, they only increase cycle time. And by the way, they never work. Well, and what some people are thinking, but wouldn't dare to tell you, sorters are useless. Well, so at the beginning of the project, there was this feeling of how hard can it be, just get on with it. So we did. And during the first month of investigating the project, it was very, very surprising for us why sorters have such a difficult stand within our fab. And I would like to tell you what it is. First of all, sorters are used as kind of a problem solver. This means whenever you have a problem at your tool, some wafer got broken or got mixed up or you're missing a wafer, you go to a sorter. So you're always in a bad mood when you go to a sorter because something is broken. And also these error recovery scenarios are always quite complex. So you really have to know what you're doing. Otherwise you get error messages and you get even more annoyed. Not good. Next, there's the identification. Sorters can only help you if they are able to identify the wafers. So wafers have printed a barcode or a QR code on them, and only if sorters are able to read them, they can help you because then they know what they have in front of them. But if you're running experiments, you normally have processes which are not stable yet also, and sometimes you damage this identification, which makes this error recovering scenario even more complicated. Well, and then there's that almost everyone is using your sorter, because it is really used by anyone who has a problem, who has a tool, goes there and uses it. And this means that the average user for your sorter doesn't really have a clue what he's doing. And this makes it really, really hard to operate it. And next, there's the high variety you have for your sorter. Because in contrast to a process tool, where you pretty much know in which state the lot is when it enters your tool and what properties it has, you don't know it for a sorter, because for a sorter, you have to support every kind of lot at every stage of its process, and this is really, really difficult, so you get a very high variation. Let me detail this a bit. So, first of all, sorters can do different scenarios. I told you about split and merge, but there's more to it. You can notch. Notch means you align wafers in their orientation. You can flip wafers. You can check lots for their integrity, whether all wafers are inside. You can transfer wafers from one box to another, and much, much more. Then there's the substrate type. So at Infineon, we don't only have thick silicon wafers, we also have thin silicon wafers. And thin is not a proper definition, because we have thin and very thin and ultra-thin wafers, and they all behave differently. And then you have thin wafers put on glass, thin wafers put on tape, thin wafers put on glass, put on frames. So you have all different kind of combinations of materials. And not every handler is able to handle every lot. Some older handlers can actually break them. Well, then there's material protocol. At Infineon, we mix material protocols within our fab, so we haven't separated them physically. This means that different contaminations, like different chemicals, are produced on or processed on separate equipments, but they are not separated physically, and so you have to keep that in mind at all time. And it's difficult to answer the question, can you actually use a sorter for different material protocols? Well, then there's the tool type. We have different generations of sorter and from different manufacturers in our fab. And while they all can do each scenario, or mostly at least, they are doing it slightly differently, especially if it comes to error handling. And so you have to keep this in mind as well. And there's the facilities. So our fab is substructured logically in our MES system into different facilities. And this is really interesting when it comes to implementation. And there's much, much more. Well, this means that if you consider all these combinations, you end up with at least 2,000 combinations that you have to consider when you try to integrate a sorter into your experiment management system. And this is another reason why no one has tried to do it or some people have tried and then haven't done it. And so this was the starting point for our project, really. Well, I'm afraid to tell you, there is no magic trick which can solve this for you. But we got down and we locked ourselves into a room and went through all these 2,000 combinations and found that only 100 of them are actually relevant, because you don't need to create lots at the back end of line, for example, or you don't want to flip thin wafers, for example. So there are many, many combinations which are not relevant for you. With the resulting 100 combinations, well, we just went through it, found out what the priority is for them, are they feasible to actually implement them, and then we did FMEA, so failure mode effect and analysis, to see if we implement them, what would happen? Would we hurt another process or so? And so we did that, prioritized them, and then implemented the most interesting ones. Yeah, I don't want to bore you with the details because it's very Infineon specific, so you won't take anything with it. If you are interested, please let me know and talk to me after my presentation. But let me show you the results. Well, first of all, here you see the number of experiments with split that are run automatically. And I can tell you, people are using it. So we haven't done this bad a job. And just with people using these automatic experiment splits, we gain quality improvements, we gain traceability, and also we gain speed. by speed because people don't go to holiday, and so automation does it for you. So how much speed did we actually gain? Well, I did prepare a slide for it. I can't give you the actual numbers because I wasn't allowed to, but we are down to 4% on average. So this is the time a lot was waiting at a split operation and the time it took to complete this operation, including the waiting time. So we are down to 4%. And even more interesting, I have the Boxplot for you. So here's our median and our 25 and 75% quantile and the maximum value. And here you can see the effect that Dr. Morgenstern told us yesterday. So actually our median is quite okay, but our 75% quantile and our maximum is far, far away from the medium, which puts up our average. And this is exactly what happened. So if some operator had more important things to do, or if he was on holiday, then you get this extreme values. And with automation, we're actually down here. You can't see it, but I made it a bit bigger for you. So it's the minimum value is the median of the new automatic value. So this is really a result we're really proud of. Well, next to these immediate results, there's more. Because what this experiment management system actually achieved is that we separated the experiments from the developer. And with our addition that you can use sorters now, but now the experiment management system feels more complete, so you have a full set of tools you need as a developer. And this separation you can take to the extreme. What you can do is, Infineon has different sites all over the world, and at the moment, each developer develops on its own site. But of course, with the separation, you can now have developers which are at Munich or Villach, have them develop at Dresden. And this is really, really interesting for us, because at the moment, the developer in Villach developed in Villach, then the product was up and running. And then he transferred the project or the product to Dresden. So although it was completed here, he had to transfer the product. And this means you have to qualify it on new tools, and you have to, the tools are maybe not are different, or they don't exist at all because we have different tools. And this would take you back quite a lot of steps. And so this costs you very, very much time, and this is valuable time to market, and this is time you lose when you're trying to sell your product, and in the meantime, a competitor might sell this product. So this is our next big step, and with the experiment management system, the technical foundation is laid out for it. Okay, thank you very much. I'd like to conclude. I hope I could show you that having an MES, like my predecessor said, is a very, very interesting option, but don't forget the experiment management system. It's really, really important. I tried to show you why sorters are not liked in our company and why it's so complicated to integrate them into experiment management system. But I tried to show you that you get both good immediate results and the outlook that this is the enabler for remote development. Thank you very much.